Okay, in this video we're going to talk a little bit about the concept of a data store, right? So this is meant to lead into the concept of a database or a database management system. You almost always hear management system when you hear database management system. So that concept basically implies that there's some software layer around a data store, right? The database itself is the data store, and the management system is how you interact with that database, how operations can take place, how to prevent corruptions, how to ensure that the data is integrous, right? Data integrity is very important. So let's start simply, and we're just going to talk about a data store, and we're going to make a really simple program that's going to keep track of scores as if you were taking tests, and you would keep track of your scores there. So let's see what we're going to do. Add a file. There we go. New file. Scores.py. Alright, and we're going to use sort of the framework we have for a few other programs. We're going to make a simple little menu, and we'll do this fast because we've done this before. And select your choice. Alright, and we're going to have some menu options here for the user to select what they want to do. And the first option will be add a score, and then the second option will be calculate the average, and then the third option will be to exit. Actually, we'll just exit after we calculate the average, because that's realistically what's most important. So, two options, very simple program. We want to do this in a loop because we're going to be adding multiple scores. Right? So while true, and we'll just break out of the loop using the control keyword break. So if we need to get a user option, right? So selected equals input, enter an option. And add a little spacing there, enter an option. So if selected, right, that's going to be a string value because we get it from the input function. If that is equal to the value 1, then we're going to need to get a score from the user and add it to some list of scores. Alright, so we're going to want a list here, scores, and we're going to be accumulating values into this list based on what the user gives us, right? So what we want to do is call the input function, and we will have some value x, and enter a score between 0.0 and 100.0. Alright, so we can assume good data for now. So if we're assuming that the user isn't going to make any mistakes, we can convert the string into a floating point decimal. Remember, the input command gives us string data. So at this point, x is going to be holding a string. But then on this line, we're using the float function to pass in string data. This will convert it to floating point decimal data. So here, if they typed in 98.7, oops, as a string, right, 98.7, and here, this is going to be 98.7 as a floating point decimal, right? Notice the no quotes. So as a literal, this is what it would look like if we typed it in as a float literal. This is a string literal. All right, but they're both in comments. So we convert it to a float, and we will just assume that that is possible and they didn't type anything in wrong. Right? We can fix that up later. But generally speaking, when you make a program, you want to try to get it going the simplest way possible and then add improvements later. So we'll leave that as one of the later things we do. So if we have this value x, what we want to do is append that to our list. Scores.append. So append is how you add an item to a list. We started with an empty list, and now we're going to add the value x that we got from the user and convert it to a float. So that is going to be in our scores list. Right? And that's all there is to option 1. We added a score. Right? Now if we have option 2, selected equals 2, then what we want to do is calculate the average. So we just have a simple loop. Sorry, elif. There we go. Syntax is wrong there. So we use a simple loop to iterate over our scores, and we need some total value. So the total value is going to start at 0. And then for each one of the scores, so for each score in our list of scores, right, score is going to hold the value of each individual item in this list. So in the loop, we're going to say total equals whatever it did before plus the score. Okay, so for example, if we had 98.7 in here, 87.6, and 36.5. So if these were our 3 scores, the loop scores is this list, right? So it's effectively this. Score becomes each one of the items in this list, and then the loop executes with score holding that value. So here, total starts at 0. Score becomes this first value. What we're now setting a new value to total. This plus equals essentially means total. What did total equal before? And then add score to it. Right? So score is 98.7. So the first time through the loop, score is going to be 98.7. Next time through the loop, score is this value, the second item in the list. And then we take whatever was stored in total before, which is now 98.7. We're going to take that and add the new value, score. Right? And then we're going to add the new value the next time through the loop. Okay? So that's effectively what's happening here. But instead of having this list here with string literals, the list is stored in the variable scores up here. Right? And we start out this list empty, but we add up values, or we add values to that list as the user types in a value here, selected one. Right? So pretty simple so far. We get a total, and then we need to calculate the average. AVG. So how do you calculate the average? You sum up all of the items, so that should be total. That's the total sum, and then we divide by the length of our list of scores. Right, so that's very simple. The average. So print the average score of and we can print out the list of scores just so you can verify them if you want. Scores. And then we'll print out, or we'll say the scores, the following scores. There we go. Get the phrasing right here. The following scores average to, and then we'll print out average. Now we can make this nicer. AVG is our variable name. We could obviously make this output a lot nicer, but we're trying to get something working very quickly, and this really isn't the focus. This average calculation is pretty easy to do, and that's not the focus of this video. So we have 2 options. We input data, and then we calculate the average and print it out. Now, also, once we've calculated the average, we want to break out of our loop here. This is an infinite loop right now. So unless we use the break keyword, we're never going to break out of this loop. So after you calculate the average, that's the whole point of this program, so we'll just break out of the loop then. Alright, the break keyword finds the closest loop, right? We only have one, and it breaks out of that loop. Down here we can say print program done. Alright, so this is all well and good. Let's run it, test it, see what we've done. From 3 scores, enter an option, add a score. Alright, so 1, 98.7, add another score, 87.6, add another score, 36.5. Alright, and then we're going to calculate average. Okay, so the average of the following scores here is 87.6. Right? Pretty close. And Python has a little extra value here at the end, and that gets down to how numbers are represented in the system in binary. So we'll ignore that, but it's 87.6, right? So that looks correct, right? We could try some different values if you're not convinced. Python score, add a score, 10, 11, and 12. Calculate the average, 11, right? So whenever you have 3 values that are incremented by the same amount, the middle one is going to be the average. That's what happened above here. We had 3 values that were each incremented by 1.1, or decremented rather, by 11.1 points. Right, so the average was the middle one. That's the case here. So what's nice about this is we have a working program, and that's fine. But let's say we have a quiz every day in one of our classes, right? And we get scores every day. And we are deep into our semester, and we don't want to type in all the other scores. We could make mistakes, right? There's lots of different issues with that. Right, so what we want to do is, as we type these scores in, we want to save them, right? And this ties into a previous video on program state. So we need to save them. We need to have some sort of way to store them in a long-term way, right? Random access memory is volatile, right? It's not long-term storage. We want something that's long-term storage. So we're going to use a data store. And the simplest kind of data store is a file, right? So what we want to do is we want to create a file just like we've done before. We'll import OS, and we'll say if os.path.exists, we're going to be looking for our file, and we're just going to call this scores.dat. Right? And we want to see if this path exists, and if it does, right, we're going to load up that file, right? So we're going to pass on that for now. If it doesn't exist, well, we need to create the file. File equals open scores.dat, and we're going to open it for writing. And in this case, we don't have any scores to save, which is fine. But what we can do is use, we want to join up all of these scores and save them into some file. Right? So how will we store them in a file? Let's consider a new tab here. Well, basically we just want one number per line is probably the simplest way to do this, right? So how is this actually stored on the hard disk? Well, each character, since this is English characters and UTF, this is probably 1 byte of information, right? Every single one of these characters. How do we know that this number ends and this number begins? Well, that's because there's a new line character here. There's a hidden character that actually tells the terminal or the file editor to move to the next line before it prints out the next number, right? These are called control characters. We've looked at the ASCII table, and that's what control characters do. They control how the terminal or how a text editor operate. So the line feed, or the new line character, is one of those control characters. So basically, when we're reading this, we have to imagine ourselves as the computer. We know we have this first number up until we encounter a new line character. And then we know this is the completed number, right? Because we don't know after just 0.7, we could have 0.798. So we don't have any way of knowing as we're reading this number when it's over until we see that new line character, right? And so once we see that new line character, the program's going to say, okay, that is my data for the first score, and I can convert that to a floating point decimal, right? Because everything in files, in a text file, is just string data. And then we have the new line character, and then we can do the same thing. We can start scanning until we find another new line character, or the end of the file. Either way, right? If we have a new line character here, that means this one is a completed numeric value, so that's going to be one of our scores. We convert it to float. And then we have a new line character that tells us this line. We can start doing the exact same thing, scanning characters in until we see another new line, or the end of the file. All right, so this is kind of the idea. We're using the new line character as what's called a delimiter. It just is in between each number, and that way we know it's a separator. It tells us where one number ends and another one begins. So it's called a delimiter. So what we want to do here is, if we don't have this file, we need to create it. And so we want to use the new line character. So this is a string value, and it's a special control character. You use the backslash, right? That's the escape sequence in the string. And the backslash in tells Python, wait, I actually want a special character here. And the special character is the new line. So we're going to use this new line character and join all of the items in this array. We're going to join them together. So the dot join function takes whatever string value you have here, and it inserts it between each one of the values in your list. Right? So I need to check to see if it converts it to a string. I'm not sure if it does or not. We will double check that. So we'll start with floating point decimals, 87.6. My feeling is that it probably will not. Python score. So our data file does not exist. Scores.dat does not exist in here. We have our program, scores.py. So this should be false. We should open up this, and we'll try to join these scores with the new line character. And so this will be our string data that's going to go into the file. So we'll call this file data. And then we would say file.write our file data. And then finally close our file. Yeah, file.close. All right. So the thing we might be concerned with is joining floating point decimals with a string value doesn't make sense, but Python might be smart enough to automatically convert these to strings. So we'll find out here. We're going to run it real quick and find out if Python is smart enough to do that for us. Okay, yeah, so it does not like that expected a string instance. Okay, so when you're joining items together, right, it expects a string instance. So here we can say scores as strings. It's going to be a list. And just do a little for loop to iterate over this. There are much better ways to do this, but we don't know all of the tricks of Python yet, so we're just going to do a for loop. And for score in scores, so scores is our list. Score will be one of these individual values, right? We're going to convert that to a string. And then append, maybe call this string scores. There we go. then we're going to append this string version of the score to our list, string scores. Okay, so now we have a string version of our numeric data, right? And this is why types are so important, right? We have to know how to write data to a file if it's text or if it's a numeric value, right? We're just using text files because they're easy, and we can also open them in a text editor and look at them. So we have string scores now. So instead of trying to make the file data from our scores list and join that with a new line character, we're going to use our string scores list, which is the same data except it's strings. So now the new line character should be able to be inserted in between each one of those. All right, and so we're starting out with some data in here, so our file should have some data. We can delete this. We deleted the data file there, so it'll create a new one when we run it. Okay, so it has started up just fine, and we see that it created a file, and we see that it put in our data. So this is a data store, right? It's a data file that stores our data in a long-term way. All right. Now this is just the beginning part, right? This is just creating it to begin with. Let's say it's empty to start with, which it should be in our program. So let's delete our data file and see if it still works with no string data. So we'll exit this program, run it again. Program starts up. We do have a data file and it's empty, so that's fine. It's working. It creates the data file, and that's excellent. All right, so this is if the data file does not exist, right? So if it exists, we do this, and so all of this has been if it does not exist. So that's why we're creating it to start with. Right, so if it does exist, then we need to load that data. Right, so we'll say file equals open. And we want to open a file called scores.dat. We want to open it for reading, and we will say file data equals file.read, and this file may have been corrupted, right? So we want to strip off any white space at the beginning. We won't do this every time because it's tedious, but in a real program that you would actually release to the public, you definitely want to make sure some of this stuff, you want your program to be resilient. You don't want someone to modify this file and it to ruin the program. So all we're going to do for resiliency here is strip off the white space, right, at the beginning and end. And then we're going to assume, so we can close our file, file.close, because we've got the file data. And then scores, which is our list that starts out empty. But since this file exists, we know that we need to load up the values from that list. So scores is going to equal the file data we got. And we're going to split that over the new line character. Okay, so this is the file data. And you know, this might have several numbers in it separated by new line characters. Right, so splits it over a particular character and makes a list. So this line, the dot split function, is the opposite of the dot join. Okay, dot join takes a list and inserts a new line character between each one of the string items in the list. This does the exact opposite. It takes a string and separates that string by this character and forms a list. Okay, so it's important to realize these two are the exact opposite. Right, which makes sense. One of them we're loading and one of them we're saving. All right, so this creates our list scores. And then down here, just to verify everything's working, we will print out our scores. This is temporary. And we'll see if this file loads up appropriately with no data. in our scores.dat file. Okay, so exit out of that with Control C, and we see that sure enough we have scores, but one of the issues there is it printed out a list that does have an item in it, but it's the empty string. Okay, so we need to make sure that this first item, if it's just the empty string, we need to remove it. Right? So we need to remove all of the items that are empty strings in our list. Right? So we can just do a simple one for the one on top. There's a better way to do this. If you want, you would want to check all of the lines to make sure that they are empty. But if scores, so if the length of scores equals 1 or is greater than 0, so as long as you have one element in your list, and scores, the item at index 0 is the empty string, we're going to say scores.pop. And that's going to remove that item from our list. So pop removes the last item from your list. Or you can insert an index and it will remove the item at that index. So pop 0 will remove the first item of the list. In this case, they're the same thing. Okay, so and technically our list should always be at least one item. So we don't technically need this. It's usually a good idea to check to see if your list has a length before you reference an item in it. So I'm just going to leave this in because it's a good practice. But in our case, it's not technically needed because we're always going to have a value just based on how things are set up here. All right, so we run this. Now our list is empty. So that's good. That's what we want, because our list has started out empty and we don't have any items. Okay. So our initial coding is complete. So all this code so far, this is just loading and saving data. All right? And the only thing we need to do now is whenever we add a score, let's automatically save that to our list of scores. Right? So we can automatically, we're going to need to open our data file for writing. We're going to need to convert all of our scores into string values, and then we will store that entire list to the file. So basically this is all we need to do. So since we are doing this batch of code twice, I could just copy and paste this, right? I could say enter score, scores.append, and then just paste all this in here. Let's do that real quick. Copy, paste. All right, now that was verbatim. It is the exact same code, and we will save this, and let's run it, and we will see. We will add a score, and then add another score, and then we'll calculate the average, and it should exit. So we have two values. Now we see scores, we have two values. So now next time we run the program, we already have some items in our list, right? So Python scores, and I can add another score, and that one will be 76.5, okay, and calculate the average. Int and string. Oh, so I'm not converting these items to a string here. Right, so when I load up scores.dat, I need to convert them to, because this is file data is string data, so scores is actually the string version of the list, string scores. scores, right? And just like in this one, how we had to convert it to integer data, or we had to convert integer data to string data because it was storing in a file. Now we have to go the other way from string data to integer data. So that's easy. We just make a list scores. We already have that list up here. And we can say for string score in string scores. So the plural here means it's a list. So this variable is going to be one of the items in this list. So for string score in string scores, we need to take our original list of scores. Now these are integers. We're going to say scores, or I'm sorry, they're floating point decimals. Scores.append, and we're going to append the float version of string score. Okay, so string score is a string because it's one of the items in this list of string scores. And so this is basically converting all of the items in our list of string scores to the same items but as type float. And so our list of scores is now floating point decimals. Alright, so our scores dat is still the string data, and we can run the program again and calculate the average. And this time it works because we have the right data types. That's why data types are so important, right? So we get the average. Now notice I didn't have to add any items, right? I can just go right to calculate the average. So in this program, I'm saving the state of all the different scores that I've had. And so as if you have a daily quiz every day, I can run scores, I can add a new score, and I can say add that one in, and now I can calculate the average. Right? And then also I could open up this data file and add in scores. Say I got 105%. Right? So maybe there was some extra credit there. If I run this, calculate the average, it's included. Alright, so this type of data that we have created a data file. It's commonly called a data store. It's just a place to store data. And data file is a particular type of data store, right? It's a data store that uses a file as the backbone for its storage mechanism, right? So this data file is just a list, right? This list of data is what we call homogeneous. Each one of these rows is a specific type, and they're all the same type. We're not mixing data types here. Theoretically, I'm going to open a new file here. Theoretically, I could create something that has other multiple types of data, right? So Luke May, and then have information about this person, right? You would have like an ID number perhaps, right? But this is different types of data. Each line represents, so this is first name, this is last name, and you have other things here, right? Homogeneous data is each item in the collection is the same type, right? Heterogeneous data is each item in the collection is not the same type, right? So I could have cat 47 and true, and this would be heterogeneous data because cat is obviously a string. This could be a string, or more obviously it looks like an integer, and this is probably a Boolean value. So these could theoretically all be strings, but you'd be hard pressed to assume that these are all the same type of data, right? Now technically in a data file, everything, at least in our data file here, this is a string-based data file, everything is a string, and we would have to convert it to the right type, right? That's why we had to convert the types. So this is, again, heterogeneous data versus this, which all the data is the same type here, so this is homogeneous data. Now this is going to become important as we expand and start talking about records of data. All right. So one more thing I want to specify here in this scores example, and we're gonna build on this in a future video. But in the scores example, we saw here this if else. This was just checking to see if our file existed, right? If it does, this is load data, and if it doesn't exist, we save data. Right? So we might want to, especially since we're using this exactly the exact same code in two different places, we might want to make a function so we don't have all of these extra lines, because the more lines you add, the harder it is to read, right? So let's add a function up here to help us out. We're going to add a function called save data. All right, and we're going to just put this right in here. And then we'll call save data. All right, now one thing that should be said is we are referencing this list here. Okay, so string scores, we're creating a new list. That's fine. We cannot, this is in the global scope, and so we cannot change that value in our function without specifying a global keyword. So in load data, we're not changing that either, so that should work out just fine. All right, we are accessing this value scores, which is in the global scope, not in our function scope. So you can access values in a function from the global scope, but you cannot set them unless you specify the global keyword. All right? But luckily in this case we don't need to worry about that. So here we have save data. So we can just call this function instead of that big blob of code. This is a lot more readable. Save data. So we just kind of know what that means. Right? It's intuitive. So all of this code, now I can just paste in and say save data. Now this is a lot more readable. Right? I could make a function for this. That would be like collect a number between 1 and 100. Right? And that could be one function. Right? We could have a function here for calculate average. That would make our big if statement look much cleaner. You know, we could have a big function here that says print menu. Right? Print menu and get menu option. So that would make this all look a lot cleaner. So adding functions does a couple of different things. It gives you the reusability, which is really nice for save data. You see we were able to use it here and here, which saved us this many lines of code. Right? But it also, as you read through the program itself, it makes it more readable. Right? When we look in this while loop, this is just a big blob of code and it's kind of hard to read. If we separate these things out, and we'll even do it here with load data. We'll just do this real quick. Define load data. And we're just going to paste in everything from here. So now this if statement is way more clear, right? So you've got this scores list, and you know if your data file exists, then we load the data from it, and if it doesn't, then we save the data we currently have, which is just an empty list. Right? So load data and save data. So the flow is much nicer now. And then we can test this real quick to make sure it's still working. Run scores, calculate average. Okay, so that's working. Run scores. Let's delete the file. All right. Run scores. We see that the file was created and it's empty, so that's good. Add a score. We're going to add a 90. Alright, and calculate the average. It should just be 90, so that's working. So you see we didn't change any of the functionality, but this is easier to read. So these are all helper functions. They're functions that help us write the larger program, and then this is the main program flow. So this is the main program. So generally speaking, you'll have a section of helper functions above your program, and then a main program, which is the main flow of your program, where you call the other functions. Okay, so let's add a couple more functions, and we'll see how much cleaner this gets with those functions. And there's only a couple more we need to add. So this is our main program. So back in our helper functions, we're going to display menu and get user option. Right, so this is kind of a long function name. Generally, you might want to avoid that. We could just say display menu, and the assumption is we'll get a user option. But this at least tells us that we're expecting to get a value back. So we'll use this for now. And that's going to be this section here, right? We are going to get some selected value. So we can just copy and paste this up here. And then return the selected value. So selected is what we got from input, so we return that from our function. So whenever we call this function, Python essentially executes these lines of code, and it will replace this function call itself with this return value. So down here, we just have selected equals display menu and get user option. Right, so that's cleaning up our while loop quite a bit. So this one, if selected is 1, then we get the data there. And then this would be calculate the average. So we could make a function for both of those. Right, let's do calculate average first. All right, and again, the def keyword defines a function. This is just an identifier, like a variable name. So calculate average. And what do I want to do in this function? Let's copy and paste all of this. Now I don't want the break, because the break relates to the while loop. So I'm going to put all of that in here. So total, we have the list of scores up here, so I can access that. Right, I add up all the scores, I get the average, and then I go ahead and print that out. Right, and I don't need to return anything. I can if I want. I could return average, but we're not doing anything with it. We're just printing it out. So this all gets removed in favor of calling this function, calculate average. So to call the function, I use the function name, left and right parenthesis. Right. So now this is our main program now. See how much smaller it is, and it's actually much easier to read. If our path exists, load the data. If it doesn't, we'll save data. And then we enter this loop. Display menu and get the user option. Okay, so that's our user option. If our user option is 1, do this stuff and then save the data. If the user option is 2, calculate the average and print it out. And then exit. Right, so we could add another function for that if we wanted to. Right, so let's do that. This would be find get float from user, or get score. Get score is simpler. Get score from user. Right, so all of this, just these 2 lines really. We get a value from the user, store it in X, we convert that to a floating point decimal, and then return that value X. So the return value is what Python replaces with this function call after it executes the code. So down here, we're going to say X equals get score from user. Right? And if we wanted to include this part, append score, we could do that. There's multiple ways of doing things, right? We could go ahead and include this up here in our function and not return a value. So if we're not returning a value, we don't need to save the function call in a variable. And now look how clean this program is. It's very readable now. This is what our program is doing, and these are the implementation details for all of those actions, all of those functions we've defined. If our program exists, we load the data. Otherwise, we save the data. We enter a loop. We display the menu and get a user option. If the option is 1, we get the score from the user and then save the data. And then loop again, right? If the option is 2, we'll calculate the average and exit. So we will run this one last time. Hopefully there's no issues. Add a score 1. So we can add 80. Add a score 1. 90. Add a score. Well, let's just calculate the average. So we had 90 from before. I did 80 again, and then 90. Right? And so that's the average. So you see how using functions can really help for code reuse. So in the case of save data, we reused that twice. That saved us there. But also just for readability. Right? This now, the main program, has been boiled down to just a few lines of code, and it's much easier to read. And so all of these helper functions up here encapsulate that whatever behavior we define. This is just essentially an identifier name for our function, and it's explaining what this function does. It displays our menu, so it prints out the menu, and it also gets the user option selected using the input, and then returns it, right? So this is a good strategy when you're coding. Good way to use functions. Break them up. Break up your programs into functions when you can, and it helps you explain what the program is doing better. It makes your programs more readable, and also it allows for code reuse. Okay. So again, this has been a video about data stores. This is a very simple data store. It is a homogeneous data store. All of the data stored in the data store is the same data type. It's homogeneous. All right. So hopefully this has been interesting, and hopefully you learned something.